Welcome back to Zachary Zone. So let's go ahead and jump into the lesson for today. I am referencing the Texas Essentials of Knowledge and Skills for our math standard. So let's read it together. This is TEKS 8.5b. Apply the math process standards to use proportional and non-proportional relationships to develop foundational concepts of functions. We are expected to represent linear, non-proportional situations with tables, graphs, and equations in the form of y equals mx plus b, where b is not equal to 0. Very important. So if b is not equal to 0, then what's happening there? The y-intercept does not pass through the origin. Okay, that is what defines non-proportional relationships. Okay. All right, so from the standard, we see we are to use the process standards to explain proportional and non-proportional relationships. In this case, we're doing non-proportional relationships. And as I have said before, we want to make sure we're looking at those process standards so that students are able to make connections to everyday life. We're giving them opportunities to select paper and pencil or other tools as appropriate to organize and record and communicate mathematical ideas. Okay, and then always keeping in mind that they should be able to justify their arguments. So this is why I pause to say procedural understandings are not enough. If we're just teaching them steps and saying, okay, first step is this, and then what do I do next? That's very procedural. And then what happens is that when they get another question that's different, they're not able to respond. Okay, so we want to make sure the conceptual understanding is there. So what are we learning today? We want to start with our learning outcome. I can use a table, graph, and equation to represent a situation where the relationship does not start at 0. Okay, or another way of saying that is that it doesn't pass through the origin. Okay, but the key here is we are looking at non-proportional situations. And we also want to make sure that our learning outcome is always in student-friendly language. Okay, so in identifying what students need to know, let's think about what all is needed if we are presented with tables, graphs, and equations. Okay, we need to know our slope formula, the y-intercept location on a graph and in a table. What does that look like? All right, the meaning of slope as the rate of change, the meaning of the y-intercept. We also want to make sure we have the right words to explain proportional versus non-proportional relationships, especially when it comes to the slope. Okay, we want to be able to identify the constant rate of change. Okay, we want to be able to determine whether or not a line is passing through the origin. If it's passing through the origin, it's proportional. If it does not pass through the origin, it's non-proportional, which is what we're dealing with today in this lesson. Okay, and then we also want to have some knowledge about our coordinate plane. Do students know the quadrants? Okay, very, very important because we're dealing with ordered pairs. So even though a large part of our learning is anchored in quadrant 1, it's still very important for students to make those connections to the other quadrants because it's coming. Okay. And then as we move on to what students need to be able to show on their papers and screens, we want to be able to see the rule, which is the slope formula, the slope-intercept form of an equation. Okay, you also want to add to that maybe having the students label their ordered pairs. Okay, we do want them to draw their y coordinate or circle their y coordinate or however you want them to identify that. If you are using some type of technology, maybe it's that they are showing you the representation on their tool. All right, and then we are writing a sentence to explain if the relationship is proportional or non-proportional. For this lesson, though, we are specifically looking at some situations that are anchored in non-proportional relationships. So before you jump into solving problems and answering questions, let's look at some ways that you can hook students at the beginning of the lesson. On the screen, I have included some examples of situations that represent linear, non-proportional relationships. Notice that I picked situations that students are familiar with. As a way of hooking their attention, I might ask them to compare streaming services and engage them in an opportunity to turn and talk. Let's look at the phone plan. I might ask students, which would you prefer? Would you rather sign up for the phone plan that has a $170 activation fee and you pay $15 per month for 2 years? Or would you rather sign up for the plan that's on the screen for 2 years, which has an activation fee of $50 and you pay $20 per month? Okay, so would you rather pay a $170 activation fee and $15 per month for 2 years? Or would you rather pay a $50 activation fee and $20 per month for 2 years? Those are your options. Okay, what if I told you that in 2 years you would end up paying the same amount? These are the types of things we want students to discuss. Why would someone choose one situation over the other? Where are they starting? In these situations, it is a difference of me starting at $50 versus starting at $170. But at 2 years of payments, I'm paying the same amount for my phone. Okay, so that's a really, really good way to just draw students in and then present the lesson. So for these situations, we still want to emphasize the rule draw right protocol. Okay, for the equation y equals mx plus b, our m represents our slope, showing the rate, and our b represents the y-intercept, which shows our starting point. For the draw box, students should represent the relationship with a different representation than what they are given. Okay, so for this lesson, you are focused on teaching students to generate a table or graph to represent a given situation. So if you haven't had an opportunity to look at how these questions are assessed, I would certainly encourage you to do so. This is the application of understanding the meaning of the slope as a constant rate of increase or decrease. They are also applying their knowledge of the y-intercept to understand the starting point for the situation. This does not mean that you will not have negative values in the table. Why? What do we know about lines? They extend in either direction indefinitely. It just means that the negative values may not be applicable. So I have an example here on the screen to kind of stamp this understanding. So let's look at the example of the battery. I had that on this slide here, okay, for battery use. So the equation for that was y equals negative 15x plus 100. So this is what the graph of that line will look like. The x-axis represents the time in hours. The y-axis represents the battery life. If I extended this line to see what happens at 9 hours, I see that my line will be in quadrant 4 with a negative value. So here's my question that I would ask the students. Is it possible to have a negative percent on your cell phone battery? The answer is no. When the battery is at 0%, the phone dies and it shuts off. There are no negative values. Okay, so even though that line is stretching indefinitely, the negative values are a moot point here. It's not applicable. Okay, so we're going to jump into a couple of questions. But again, just remember for this, students need to be able to identify tables and graphs that align with the situations that they are presented with. Okay, so as we see on the screen, we have a situation. It says Mrs. Thompson paid a $5 setup fee to sign up for a music streaming service, then $3 per month. Generate a table to represent her cost per month. Write an equation to represent the table. And then we're going to answer the question, how much will she have paid for her music streaming service in 3 years? or 36 months. All right, so notice I did not give students a multiple choice question immediately straight out the gate. Okay, we want to make sure we're developing these concepts first as part of our lesson. The first thing I want to do is I want to identify, I want to do exactly what it says. Okay, so it says to generate a table to represent her cost per month. So before I get to my rule, let me just see what I'm dealing with. All right, so I see here I have a $5 setup fee. So that's where I'm starting. I'm starting at $5. And then each month I'm going to have $3 per month. So let's think about what we talked about in previous lessons. My y-intercept is represented by the $5 setup fee. Okay, so I know it's not proportional because I'm not starting at 0, 0. I'm starting at 0, 5. So I'm going to generate my table. When x is 0, y is 5. Okay, and then each month is $3. Okay, so in month one, how much will I have paid? A total of $8. The setup fee plus the $3 per month. In month two, how much would I have paid? Well, I have to add three more dollars to my last total, which gives me 11, because that includes the setup fee plus 2 months of service. Okay, and then at month three, I have my setup fee plus 3 months of service. So I'm at 14. Okay, so I now have 4 points. Again, as a teacher, you can determine how many points you want the students to represent. Okay, so in looking at this, I want to determine my slope, which I kind of have a hint here because it says $3 per month. But let's think back to rise over run. Rise being our differences in y's, run being our differences in the x's. So I see here I have plus 3, plus 3, plus 3. Okay, and then for my x values or my run for my slope, I have plus 1, plus 1, plus 1. So it checks out that my slope is 3 over 1, which is 3. Okay, and I just applied the rise over run. Okay, so that's one of my rules to get my slope. All right, I generated my table. Okay, so to write an equation, I'm going to use my slope and my y-intercept. And so my formula there is y equals mx plus b, or the slope-intercept form of the equation is y equals mx plus b. I substitute my values in. I have 3x plus 5 for my equation. So now if I wanted to draw a graph of that, or I could put that in my calculator and generate a graph, okay, I'm going to attempt to draw a graph here. Might not be completely perfect, but okay, so I have my origin here, x-axis, y-axis, and I'm going to do this by fives. All right. And so I see here that I have a point at 0, 5. I have a point at 1, 8, so I'm going to guesstimate. It's going to be right about there. I have a point at 211, which will probably be right about there. And then a point at 314, which will probably fall right in there. And then I draw my line to connect the dots. And so we see that a graph of this equation will look something like this. And so now to answer my question, how much will she have paid for her music streaming service in 3 years or 36 months? My question to my students would be, where would I substitute my 36? Not 3. Do not substitute 3. Do not say 3 because it's not in years. We're talking about months. Okay. So where would I substitute my 36? I'm going to substitute it in for x. Y equals 3 times 36 plus 5. So I have y equals 108 plus 5. Y equals 113. So now I can write my equation. I can write my sentence to answer the question. Mrs. Thompson will have paid $113 for music streaming service for 3 years. Period. In this situation, they told us to generate a graph to represent the total cost of the subscription at the end of the month. So it says a gaming subscription has a $10 startup fee plus $5 per week. Generate a graph to represent the total cost of the subscription at the end of the month. Write an equation to represent the graph. What is the total cost for the gaming subscription at the end of the month? So instead of us generating a table and moving to a graph, we're now going to generate a graph and move to a table. Okay, it all works the same. So again, we want to be able to give students this practice to move about this interchangeably. Okay, so it's up to you. I'm just going to go ahead and use my draw box to make my graph. And so again, I'm going to attempt to freehand this and draw a coordinate plane. I'm going to use my 5s again because it seems to be working for me. At least I hope. Okay, and so it says a gaming subscription has a $10 startup fee. Well, if it's a $10 startup fee, that means that my y-intercept is at 0, 10. $10 startup fee plus $5 per week. Okay, so in week 1, I've got to pay my startup fee plus the $5 for the week. Okay, so then that means that at week 1, I'm going to be at 15. Okay, then at week 2, I'm going to have to pay my startup fee plus 2 weeks of fees. So at week 2, I'm now going to be at 220. Okay. And then I'm going to connect my dots. So I've generated my graph. Okay. So again, I applied my rise over run. Okay. I see here that I have $5 per week. So 5 for every 1. So an increase 5 up for every 1 week. Remember, our X is representing our weeks, and our Y is representing our cost. And I think that's very important for us to identify what the X and Y axes are representing. Okay, so once again, our X is representing our weeks, our Y is representing our cost. Okay, and so we see here $5 per week. So for every $5, we have 1 week. 5 over 1, rise over run. Okay, so if I were to write my equation in slope-intercept form, I see that my slope is 5 and my y-intercept is 10. To generate a table for this, I see that when x is 0, y is 10. When x is 1, y is 15. When x is 2, y is 20 for my graph. And so now I can keep going with that, applying my rule. Okay, so I see here there's a constant rate of increase. Okay, as my x increases, my y increases by 5. So when x is 3, at week 3, my cost is $25. And at week 4, my cost is $30. So now I can answer the question because we're at 4 weeks, which is a month. What is the total cost for the gaming subscription at the end of the month? The total cost for the gaming subscription at the end of the month is $30. And that's it. That's it for this lesson. Again, I want to make sure that we're stamping the learning here. So keeping in mind that for this particular standard, we're looking at situations, okay? And the students have to be able to identify either a table or a graph that represents those situations, whether it be positive slopes or negative slopes. But we're really focusing in on non-proportional relationships, which would be your relationships or equations that do not start at 0. Okay? All right. Thank you so much. Until next time. I want to share with you my website. I have started my own website for professional learning for teachers. It is www.grayjaysimagination.com. It is in honor of my son. But as you can see here, I am Sherry, your instructional leader. I do bring experience as a principal, an instructional math coach. My degree is in math education. I'm currently working in research in math education at the university level. But at the end of the day, from the bottom of my heart, I am still a teacher. I love teaching. I love working with students. I love working with teachers. I just want to say thank you for what you are doing in the classrooms. You make the difference. All right. Have a good day. Talk to you later from Zachary's Zone.